أرحب بكم في هذا الويبنار الحلقة الرابعة. في هذه الحلقة نستضيف دكتور رودني روزاليا في ماسدونيا من أصول هولندية. يشارك معنا اليوم في توبيك مهم جدا، في حديث شيق ومهم عن دور الالتهاب في تطور وصعود مرض الكوفيد 19. كثير من الابحاث الحاليه تشير الى دور الالتهاب وعناصر الالتهاب المناعيه في الالتهاب، ومما يؤديه بعد ذلك الى ظهور الاعراض المخيفه التي تؤدي في اسوأ الاحوال الى وفاه المريض في هذه الحاله. استاذنكم ايضا راح اتكلم باللغه الانجليزيه. حاب ارحب بزميلي اللي حيكون معايا في هذا الحوار، الدكتور فيصل منشاوي. دكتور فيصل تسمعني؟
ايوه اسمع.
كيف حالك دكتور فيصل؟
كيف حالك حبيبي؟
تعرف بنفسك يا دكتور معلش؟
طيب اسمي فيصل منشاوي من جامعة المذكورة، كلية العلوم الطبية التطبيقية. أشكر الدكتور مشرف على الاستضافة، وإن شاء الله يكون ويبنار مفيد للكل.
شكرا دكتور، شكرا، رحب فيك. Rodney, how are you?
Hello, great.
How are you doing, my
Thank
friend?
you for. Yeah, I'm good. Thank you for the invitation.
Of course, anytime. It's our definite pleasure, Rodney.
To the audience also, thank you for your attendance. I'm looking forward to present to you guys a little bit of what we do here at our clinic in regards to COVID-19, and I'm also very happy to share with you guys my insights, my let's say personal view on what COVID-19 is, looking at it from the immunological perspective. I'm saying that I'm trained as a immunologist. I'm not a clinician. Me and Mushraf, we go back, I think, quite some years, perhaps by now.
11 years, my friend.
Yeah, exactly. We met during immunology conference in Sardinia, and since then we have built a relationship that goes beyond only fun and games. We're also we respect each other very much professionally, and I'm really appreciative that he thought about me to share with you guys a little bit of immunology from my background. So I did my PhD in especially in tumor immunology vaccine development, where we were characterizing or formulating nanoparticles, biodegradable nanoparticles, to use as cancer vaccines, therapeutic cancer vaccines. And if I believe I can share the slides, right? I was trained in the Netherlands. I did my PhD, all my academic studies in the Netherlands, and then I traveled around Europe a bit with several postdocs prior to relocating in Macedonia purely for, mostly for family reasons. My wife has a firm with the production unit in Skopje, in the capital. My wife is Swedish, but with Macedonian background. And it's much more profitable to have the production hall here and then export all the goods to the EU than having the production hall in Stockholm. So since then I'm here for about 3 years now, and I had to slightly transfer from field of work from immunology and related to cancer. I'm transferring, or I've been focusing on immunology in cardiovascular disease, especially cardiac surgery. And you will see later on that basically the body has a very unique way react to any form of stress, and that reaction can be tracked back to how the immune system identifies any foreign invader, whether it is a sterile invader or a non-sterile invader, for example, a pathogen. So yeah, I was explained that not everybody's background is in hardcore immunology. So just a brief introduction on the immune system. We are all aware that there is two compartments of the immune system: the innate and adaptive immune system. And basically, the innate reacts to any form of stress, external stress, and then the adaptive immune system follows. The characteristic is shown here in the graph, that the innate peaks at a very early time point, usually within a few hours. And then what is followed is that the adaptive immune response takes over. The hallmark of the adaptive immune response is that it induces immunological memory, which is very important, for example, or at least we're hoping that immunological memory will be strong enough to prevent reinfection in the case of COVID. Yeah, so the adaptive immune system characterizes itself by antigen-specific responses, which is then instigated by professional antigen processing presenting cells that upon uptake of a pathogen processes these and then presents it to T cells. And these T cells then multiply and then go do their job and kill the invading pathogens. So as I mentioned, my background being in nanoparticle cancer vaccines, I think that you can notice the similarities. When you want to make a very potent vaccine, you actually need to replicate the characteristics of a virus, or preferably alternative also of a bacteria. But usually when you're looking at nanomedicine, nanovaccines, you're working in the range of viruses. The common viruses, there are much larger viruses, but in this case, I hope you guys can appreciate the similarity. Just a second. Yeah, I hope you guys can appreciate the similarity. So we were making vaccines that look quite a bit like the corona, and the vaccines had a size of around 200 nanometer. And as you can see, both electron images point to the similarities of a cancer vaccine and the coronavirus. And because of these similarities, you can actually have a very potent vaccine that if you test it in experimental models, in this case, a mouse model for melanoma, you can see the lower curves that the outgrowth of tumor is much, much slower when you use a very strong virus-like vaccine compared to if you do not treat. So for me, seeing how the coronavirus, the SARS, is developing and what it's doing with the immune system is very intriguing, because at one point you're in the lab trying to replicate what corona is doing, but then when you are faced in daily life with what corona is actually doing, it's counterintuitive, you know, to the damage that it's eliciting on our daily life on at the global level. It's yeah, unfortunately, in a manner that I think since the Spanish flu, perhaps the global population has not been impacted in such an extent. So yeah, my expertise is at least what I feel the most comfortable talking about is in immune activation, inflammation. But to give you guys a whole scope of what is going on, I will also briefly touch topics that perhaps some of you in the audience or Mushra, Faisal are also their area of expertise. So if you have questions or discussion points, I will be looking forward to the next section of the seminar, where we will share knowledge and share experience, share our expertise with each other. And I think that will be the great benefit of such a seminar. So yeah, how did it start? How this pandemic? We are all aware that somewhere in November, December, China started reporting cases of unknown of patients presenting with symptoms usually attributed to respiratory viruses, but the symptom severity and the extreme manifestation of pneumonia was not resembling what they have been seeing in the past couple of years. Perhaps many people are not aware, but in China, these kind of outbreaks happen on a yearly basis, but often most of these outbreaks are caused by influenza viruses, typically the H1N1 variant. And it's not so frequent that you have the coronavirus causing this level of pandemic. And luckily, because coronaviruses tend to elicit, like what we're experiencing now, a much more aggressive attack on the global population. As of yesterday, this is the current status in the world. I think that it's pretty clear that United States is taking over the lead as the ground zero of the COVID-19 pandemic. I think they're close to the death toll. If I'm not wrong, CNN reported yesterday also a death toll reaching 10,000. The estimates is that around 60,000, 50 to 60,000 people might or likely will succumb to the pandemic in the States. Brief, I will try to go through the slides quick, but a brief introduction in what the coronavirus does. It's a positive strand, positive RNA strand virus. It infects, it enters the tissues by binding to the ACE2 receptor, which is highly expressed on several tissue, several organ tissue of the human body, and the expression level also is mirrored in the pathology, with a lot of patients reporting, of course, lung respiratory problems, but also kidney, liver, and a lot of patients also, I believe it's a bit underreported, but a lot of patients also present with diarrhea, and that is likely related to the high infection rate in the colon. The origin, I don't know how it is in you, in your family, but I have uncles and aunties that read a lot of Facebook posts, and one of the conspiracy theories is that somebody made this virus in the lab to then block the rise of emerging economies. Of course, it's a
that's everywhere at the moment, Rodney.
Yeah. So it's a funny. I struggle to comprehend how convinced the average person is of such a theory, such an alternative theory. But luckily, we have science, and we have also hardworking, noble scientists that counters conspiracy theories with facts and data-driven, data-supported statements. The origin of the current SARS coronavirus 2 is likely in bats, particular type of bats. I believe, yeah, it's written here, Rhinolophus affinis bat. I'm not a biologist, so I struggle with the Latin pronunciation, but it's a bat that I think, if I understood correctly, it didn't even directly transfer, but it transferred through it passaged through a host, a natural prey animal of the bats, and these prey animals are then sold on wet markets in China. And I am not sure if you guys, back in 2007, there was now I think it's going to be by definition a landmark paper describing that the practice of having market and close proximity of humans and animals will likely lead to a transfer of disease, zoonotic increase in zoonotic diseases in humans. And yeah, 10 years later, we have faced, if I'm not wrong, 3 of such epidemics, endemics and pandemics. The MERS, SARS-1 and SARS-2 are all tracked back to the transfer of zoonotic viruses.
Archetype zoonosis, really. You see a leap.
Sorry?
It's an archetype example where you see exactly a leap from human, from
yeah.
animal to
I would, if there's any geneticist in the audience, I would strongly recommend you to read this article. It's very interesting to see how they trace back the exact viral components where it was coming from, and I recommend this paper. Yeah, so this moves us closer to the immune pathology of COVID-19. I was wondering, so of course what we see is that the immune response is deregulated in COVID-19 patients, and it can be very simple that you have a higher viral load and the immune system can simply not deal with it, and this causes the cytokine storm. Yeah, but that's of course that is happening, but it looks like that would be a too simplistic explanation for the extreme pathology that. So what is, at least from my interpretation of the current literature, the coronavirus infects through the ACE2 inhibitor, as I mentioned. The ACE2, not the ACE2 inhibitor, the ACE2 enzyme. This enzyme plays a role in the conversion of angiotensin. Where do I have it? Yeah, the ACE2 enzyme is a cell membrane bound enzyme that converts angiotensin 2 into angiotensin 1 until 7. And actually, angiotensin 2 has a pro-inflammatory effect on the tissue, so a local pro-inflammatory effect that is shown in this in the red field. And angiotensin 1 till 7 has an anti-inflammatory effect. So what SARS does actually is when it infects through ACE2, it blocks the conversion. So you have a local accumulation of angiotensin, which then promotes vasoconstriction, inflammation, fibrosis, and proliferation. This leads to hypertension, cardiac fibrosis, thrombosis, and acute respiratory distress syndrome. And these are the clinical manifestations, but because of the inflammation that you see here, so the fact that you have higher levels of angiotensin at the local environment, this triggers the inflammation that, in my opinion, sets the tone for what is to come. So yeah, the immune pathology is it's pretty complex. it proceeds through failure of the innate immune system to clear the virus. So the NK cells are not able to clear the virus. In the meantime, you have antigen presenting cells that take up the virus. They get triggered through TLR3, toll-like receptor 3 mediated antigen pattern recognition receptors. I'm not Mushraf or people in the audience, if I'm skipping certain topics, please just write them down and we can discuss a little bit more in detail if not everything is clear regarding.
What we can do, Rodney, is once it hits the half an hour as agreed, we can then allow to retrieve back to some of the topics you mentioned.
Yeah, definitely. So the virus triggers the immune system through a toll-like receptor mediated pathway, as most pathogens do, and this then catalyzes the immune pathology. You have the adaptive T cells coming in, which at that point have difficulties to overcome the viral load and to kill infected cells. They massively start killing infected cells, but with the killing of infected cells, a lot of self-tissue, self-antigen is released in the local environment that then triggers a form of autoimmune pathology, which is characteristic of the COVID-19. It's quite clear, I mean, that the immune system is playing a role. I believe that I will be able to share with you the slides for your own reading afterwards. So my apologies if I'm going through a bit fast. So not only the T cell immune response is activated, but of course also the humoral immunity is triggered with the characteristic early production of IgM antibodies, followed by the antigen-specific IgG. And so with as I mentioned, the T cells come in, the innate immune system is already there. Neutrophils, macrophages are there. They are faced with opponents, let's say 100 to 1. They are in panic. They're secreting all types of messenger molecules, danger signals, so-called cytokines. And this cytokine attracts more and more immune system, and this creates local hyperinflammation that, depending on the tissue, manifests as organ dysfunction. And in the case of COVID-19, it's the lung pathology is very much characteristics. Now, early studies have shown that the several cytokines are increased in, and it's proportionally increased according to the clinical severity. The two COVID-19 and cytokine storm are basically close to used interchangeably in the pathology. And here it becomes actually interesting from the immunological perspective, is that most the immune system actually becomes your worst, your primary enemy. It's not the virus anymore, but it's the immune system. The immune system causes this well-described organ failure, and this is not only this development or manifestation of organ failure is not characteristics only of SARS, but most bacteria, or even after a car accident, if you had a really severe car accident and with multiple trauma, you also have a similar pathology, and depending on the individual, this pathology will be very severe, very extreme, and people can succumb to the consequences of hyperinflammation. So then what is taught is how to control hyperinflammation. Of course, you can use several immunosuppressive modalities to combat this. If I go a little bit further, yeah, so basically, this is a hallmark of immune deregulation. It first starts off with hyperinflammation that is causing the clinical picture of multi-organ failure. If an individual survives this phase, often the body, the hyperinflammation is turned into immune suppression, and then so basically the immune system does not have the capacity to deal with a second pathogen, and these patients then develop secondary infection, which is also very prominent in COVID-19. It's let's say it's less reported because unfortunately a lot of patients pass away in the first phase, but those that survive longer, 2 to 3 weeks in the ICU, a lot of them develop secondary infection. And the reason that they develop secondary infection is because the COVID-19 the immune system is completely exhausted. The T cell
Hello?
Hello. I see.
I think the connection might have gone.
So you still hear me, Mushrif?
Yes, I can hear you. I think Rodney's connection went missing.
keep themselves in check.
Oh, there we go.
And with that, if you then retrospectively, this is, I think, a quite nice paper as well. If you look at clinical predictors, biomarkers of outcome, patients that passed away, they have much higher levels of interleukin-6, which is a pleiotropic cytokine with multiple functions depending on the situation, pro-inflammatory and anti-inflammatory. And actually we see the same in cardiac surgery patients, that those that have an adverse post-operative outcome, they also have a much higher level of interleukin-6. Interleukin-6 is then one of the control arms of the production of C-reactive protein. And what is commonly also observed is that the heart, either directly or indirectly, also suffers because of COVID-19, and this is characterized by high levels of troponin, indicating myocardial injury. So treatment, yeah, one thing is to control the immune pathology. However, it's a very tricky thing to do. Unfortunately, when the immune system goes full tilt, it's very difficult to still control because it's triggered by the antigen. So at the moment of formally, officially, the treatment of COVID-19 is mostly supportive. It's respiratory support, and because they are starting to, they have recognized the role of cytokine storm syndrome, there is a lot of preliminary clinical research showing how to the potential of blocking the cytokine storm, and with that also that a lot of drugs are being evaluated in a fast track approach to hopefully
I was just going to say, this kind of opens the door for the many questions we have.
Yeah. So I'm looking forward to that. So regarding the treatment, as you may know, they are talking about flattening the curve. It all relates to the country-specific healthcare capacity. For example, if you compare Germany, that has a very high proportion of ICU beds for their population, Germany, let's say, would be able to cope with a much bigger peak in infection rates compared to Sweden, for example, that, if I'm not wrong, has about 20-fold less ICU beds for each thousand inhabitants. yeah, so immunopathology and how to treat. There is a trial that showed very promising results that if you block IL-6, you can control the disease severity and speed up recovery. From previous literature, it is my opinion that single monotherapies are not sufficient, because when you reach the point that the immune system is completely deregulated, there are many cytokines that are in interplay, and all of them do exert their own level of damage. But there are, of course, some hallmarks: IL-1, IL-1 beta, interferon gamma, TNF, IL-6. Those are basically, if you would like to approach it from a monotherapy perspective, which for the big pharma is, of course, more attractive, you would indeed want to block specific pathways. In our clinic, how we deal with immune pathology is that we have a broad aspecific cytokine sequestration that then we aim to control the level of hyperinflammation to prevent this organ damage, and to also prevent that the system goes from hyperinflammation to immunosuppressive state. For this purpose, we use extracorporeal blood purifications, especially the Oxiris. As a disclaimer, I'm not in any way connected with the medical device company, the pharmaceutical company that produces the Oxiris. We really have promising results. What it does actually, it absorbs cytokines quite efficiently. So in other words, controlling the level of lowering the peak of hyperinflammation. I have a video, perhaps because of time, you guys can look at it, how the procedure proceeds in your own comfort. So in our clinic, we are a tertiary clinic specialized in cardiovascular disease, and we see a lot of manifestations of viral infections presenting as acute myocarditis. And we have quite a high success rate with treating patients with fulminant myocarditis using this approach. And when we look at the cytokine states as a marker for disease outcome, as you can see that patients that we are not able to control the immune pathology, those that unfortunately succumb to whatever condition they were admitted for, in this case, commonly myocarditis. If you're not able to control the IL-6, these patients fare poorly. However, when you are able to control the IL-6, these patients recover. And that is basically the message of that, is that, that it is possible to control disease severity by controlling hyperinflammation. And we extend this treatment approach also to other conditions, bacterial sepsis, for example, where you see the same promising effect. And the main issue with these kind of treatments is when to start. If you start too early with absorbing, sequestering pro-inflammatory cytokines, you might disrupt the antiviral response. If you start too late, you might already could already have led to the organ dysfunction. So that is something that we try to figure out, but it's quite difficult. Also, the literature is not helpful in this case, because these are quite novel, innovative approaches to control the immune system, but there are no large randomized control trials that showed systematically which is the ideal time point. And of course, you're facing quite heterogeneous patient population, so it might be tricky to ever have a set protocol to start treatment. Sorry about that. I'm trying to fill in this void. I submitted a grant to treat patients with this modality, a randomized approach. Some patients will be treated with a standard supportive therapy, and some will with the Oxiris. And we aim to replicate the same effects that we are seeing. Is that when by controlling inflammation, you lead to patient recovery instead of patients with the hyperinflammation, uncontrolled hyperinflammation that cannot be recovered. I would like to close off the presentation with one COVID patient that we have currently in the clinic. That is one that is actually a very interesting case, because not only does the patient have COVID, but the patient also has a ruptured abdominal aneurysm. So it's really challenging case. And I'm just sharing with you some of its of the biomarkers. The brown triangle, I don't know if it's clear on the screen.
Yes, it's fine.
The brown triangle indicates when the patient was operated, so to the rupture fixed, and immediately following the surgery, the patient was placed on the Oxiris, and you can gradually see that at the peak of the immune response, when the patients are placed on the Oxiris, you see a decrease in the immune activation. And so the theory is that as long as you can control the immune activation, you can you can permit just sufficient immune activation to kill the virus without causing the organ dysfunction. So, but this is a very challenging case, and I think it's going to take a week or two to see whether our approach in this setting, where it's complicated by the abdominal aneurysm.
How was the viral load, Rodney? How did the viral load look?
So it's pretty high. They did two sequential. I'm not aware of today's results, but the first two tests did not show a big difference in the viral load. The CT values were around 22, in our lab, suggesting that it's pretty high at the moment. So
there's a decrease in the inflammatory response, but we haven't seen yet a following drop in the viral load.
Yeah, exactly. So the let's say the downside, if you can think of an if you have to be really critical and state a disadvantage of the RT-PCR, is that it will the viral load immediate viral destruction. You will still have viral RNA left in the system.
Yes, remnants of the RNA will still be around.
Exactly. So you might be the lack of difference in the CT and the viral load, at least from our interpretation, can be due to still presence of viral RNA in the system and not active viral, but viruses. So, but tomorrow, we might have a better idea about what is going on with this patient. Yeah, so to close off the first part, this is the team that we collectively work on, let's say, research at our clinic. There is not really a true research division, but we have a lot of passionate clinicians, ambitious researchers that identify intriguing clinical cases, and we study this further. And my role is that I support these activities with my background in medical research. So, guys,
thank you very much, Rodney. It sounds. I want to thank you for the very informative presentation, and thank you for taking us through your line of work and highlighting the many aspects that I'm sure can help us feed into the many curious questions that are hopefully coming your way in the coming few minutes. So I'll try to go straight to the point in terms of basic immunology and viral responses. So what is the appropriate immune response on the level of the cytokines to a viral infection, Rodney? What can you tell us about that?
So the type of immune response is dictated by the type of virus, the type of pathogen recognition receptor involved. In the case of corona, in case of SARS coronaviruses, it's mainly the TLR3 pathway, but also RIG-I pathogen recognition receptor. These are both cytoplasmic pathogen recognition receptors.
RIG-1, MDA, intracellular kind of components that lead to the activation of the type 1, type 2.
Yeah, but I've also read some articles. That's where the literature becomes a bit blurry. Because, for example, I read also yesterday that TLR4 might be implicated. It's been hypothesized that in the absence of TLR3, TLR4 mediated immune response would be triggered, and that would produce a different cytokine profile than when TLR3 is triggered. When TLR3 is triggered, the hallmark cytokine is type 1 interferons.
Very interesting, because TLR4 is conventionally a bacterial.
Yeah. But the TLR4 can bind several. So indeed, when we were studying, when we were young immunologists, we were taught that TLR4 binds LPS, and
yes.
that's it. And that LPS binding leads to IL-1 beta production. But in fact, in the last 10 years, they have uncovered several other triggers of TLR4, also heat shock proteins.
Well, also cytokines of the pro-inflammatory nature play a role in activating TLR4 as well. So we've seen some papers coming out that talk about the link between TLR4 and TNF.
TNF triggers the...
So not directly, but being TNF is released during bacterial infections. It works as a marker also for TLR4 activation. Now, whether that's directly or some intracellular molecule involved, we don't know. We don't know exactly, of course, but the hypothesis is out there.
So it can also it can become even blurrier, that because depending on which antigen presenting cell you're looking at, some of them express the increased expression of pathogen recognition receptors in the case of a danger activation, and some of them decrease the expression level. So I can imagine that perhaps macrophages, when they get infected, they increase the level of TLR4, and this is the increased receptors then perhaps are more sensitive to bystander antigens that are released as a result of the overall picture of immune destruction of the tissues. So yeah, what causes what is not
black and white.
Yeah. But if you have, most likely, if you would have a very isolated experimental in vitro model, and you purely given the fact that it's a positive strand RNA virus, it will likely trigger TLR3.
So it's interesting that you say that, Rodney, because Promichara et al., a reference I think you've covered also in your presentation, looked at TLR3 and TLR7 in the review that he presented. He's from Thailand, by the way, for people who are interested to go and look, and we'll try to put all the papers online for you to see. And he suggests that there's an intracellular roll through RIG and MDA5 that then leads to the activation of the cleavages NF-kappa B, IRF3, which then leads to the activation of the interferon gene, and therefore further production of interferon gamma in this sake. Which leads me to then asking you about the adaptive and the cellular immune response to a viral infection. What do we know about that, Rodney?
So the adaptive immune response is the direct killing is mediated by T cells. That their role is to T cells, they would then after being programmed, they would destroy infected cells, thereby limiting viral replication. The other arm of the adaptive immune system, the B cells, simultaneously in parallel also produce antigen-specific IgG, which then blocks viral entry, and collectively they're supposed to clear the virus.
And how important is that in the level of the infection? In a viral infection, do we depend on the IgGs, or is it mostly a cellular-derived immunity?
It's a very challenging question. So let's say from the top secret inside information that I've received from colleagues working in the field regarding antibody response, they data suggests, which is not very, say if it turns out to be true, is that depending on the initial viral load and thus the clinical severity, the antibody response is too weak to not necessarily to neutralize the virus, but the titers are too low to probably have played a significant role. At least that's how they're interpreting the data.
And it corroborates with other data that's been out there. So if you look at Havre et al., one of the first papers that record an increase in IgMs and IgG, but it kind of appears very, very much delayed in the infection, sometimes around day 9 or 10.
Yeah, that's the usual course.
It's usual course, but how that course meets the viral infection. I don't know if Faisal has any input on this, but whenever you see the viral course be subsequently following the chronology of the viral infection, when it moves quite fast in the beginning of the infection, and having that IgGs are delayed, it's quite controversial to see to discuss really what the critical role for IgGs are in the fight, against corona. My question also goes back to the CD8s, which you mentioned very elegantly here. When we see this production of CD8s, we also know that there's a phenotype of a Th1 immune response in the viral infection. Can you also tell us a little bit about the balance between Th1 and Th2, and why Th1 T helper immunity is more beneficial against the viral infection?
I'm not fully aware whether there is one particular arm of the immune system, let's say in the cytokine profile, that dictates the clinically observed efficacy of viral clearance or not.
Is that based on the cytokine profile? Because you see some IL-4, you see IL-10, you see IL-12.
Yeah, because when you look at the single cell level, you would arguably be able to state if this is type 1 or type 2. There are genetic markers to distinguish whether you're looking at type 1, type 2, Th17, or even type 9, type 21. At the single cell level, you would probably be able to distinguish which is what. But to be able to, in my opinion, to be able to really strongly state which type of immune response is crucial for COVID-19 or for SARS, you would need to do some knockout or knock-in studies than in experimental models to see, to evaluate whether you lose control when you knock out a certain, not even cell type, but immune profile.
So you think even though the immune profile of interferon gamma being important in the infection, in fighting the infection, even though the timing of it, as you will elaborate, hopefully there come a few questions, even though the timing of when interferon gamma is produced, having the source of interferon gamma being linked mainly to a Th1, CD8 phenotype and milieu, does that not kind of highlight what direction the T helper cell should go?
I would not be surprised that if you look at the expression levels, the systemic levels of cytokines during, let's say, the peak of the anti-SARS immune response, that you would see a very broad profile, and you will definitely detect in, let's say, if you take the general population, you will generally detect high amounts of interferon gamma, type 1 interferons, and other characteristic pro-inflammatory cytokines. So in those terms, yes, you might be looking at the type 1 profile, but I would not be surprised that at the peak of the immune response, the immune system is already signaling that we are at risk of hyperinflammation, so that other, let's say,
Th2e.
Exactly. And then you might see a higher levels of IL-4, IL-10 coming up, and that probably also is what you're seeing, because those are important to determine the isotype switching and the breadth of the ensuing antibody response,
which appears later on. So what you're trying to say, Rodney, is while it is initially or preferably a Th1 immune response, you would need Th2 to counterbalance Th1 and to allow the humoral immune response through IgGs to then present itself.
If you can notice, I'm really careful in grouping what we're looking at, because you have an intricate, you have a multifactorial system during different phases of the anti-SARS immune response, and depending on which phase you're looking at, you will have a dominance of a particular cytokine or a particular group of cytokines. And in our mindset, people like to group things. So you would then say, hey, this is perhaps Th1, or this is Th2, or this is Th17, or actually this is immune suppressive profile. But in my opinion, it's rather difficult to state
exactly what type of phenotype.
Exactly.
Yes, Faisal.
I think this is a good discussion point, because that will give us a question of how is the developed vaccine that correlate with the long-term protection, either that neutralizing antibody matter or the CD4, CD8 T response matter. So I think the combination of those two.
But then we'll struggle, I think, because so on the heel of what you were saying, Rodney, if we cannot then identify which immune milieu is dominant, at least, so not the sole, so not only Th1 or only Th2, let's say a more dominant feature, then won't we struggle in finding treatments then to what immune response we can elaborate on? Where do you see the balance is?
No, I think that, yeah, I can understand where that question is coming from. I think that the immune reaction to SARS is so heterogeneous, and that we are not in the phase yet that we can really characterize which type of immune response predominates. And because you also have patients that actually that have a very arbitrary weak activation of the immune system based on cytokine analysis, and they clear the virus and they're fine.
Is there no group of cytokines that have been associated with susceptibility and another group associated with the resistance? Have we not managed to kind of identify? Because from the papers that have been coming out, Rodney, we do see a push towards the IL-6 and interferon gamma if produced early enough, but not later, to clear the infection maybe early on. Maybe you can elaborate on this more about the timing, because I remember you said something about how sometimes it's too much too late.
There are some individual case reports that indeed pinpoint to particular group of cytokines predominating. The paper personally that I often refer to, the one by, see if I can, Ruan, this one, pointed to multiple cytokines being upregulated, among others are interleukin-6, but interleukin-6 is a pleiotropic cytokine that in my opinion cannot be really or should not be grouped into either Th1 or, it's a cytokine that generally signals, let's say, danger. The individial is in danger.
Dire state, yes. It's associated with mortality as well.
Yeah. I see. If in my local cohort here in cardiovascular disease patients or septic patients, if I see IL-6 going out of control, I already can make certain predictions. And
is it more indicative than interferon, would you say, and IL-10, because you see an increase in interferon and IL-10 also in patients in the ICU?
Yeah, but here it comes down to at what time point you're measuring.
Can you elaborate on the time point, Rodney? Because I know you've mentioned this a few times. Can you elaborate to us about the time point of measuring? When is it considered good? What time point to look at? And can you elaborate on this point?
In mouse models, excuse me for going to a more simplistic view. So in mouse models, you see a different kinetics in which cytokines come up first and which ones come up later. And when you mention, for example, IL-10 is considered immunosuppressive, let's say a controlling cytokine rather than a cytokine with pro-inflammatory characteristics, or one that governs cytotoxicity of the adaptive immune system. So if you would measure, let's say, early during a viral response, there is a chance that you would not detect a high level of IL-10, but you might already detect higher levels of IL-6 and TNF-alpha. If you measure later during the response, IL-10 has increased, and this IL-10 increase can be two things. It can be simply production to support the ongoing mechanism, the ongoing immune response, or it can be seen as a signal that the immune system is self-regulating and transitioning into this immune suppressive state.
And is that associated with the increase in CD4, CD25, FOXP3 T regulatory cells? Do we see also an increase in that cellular response?
I'm not sure, but
IL-10 is not only produced; it's mainly produced by the T regulatory cells, but it can be produced by different cells.
Yeah. And I think I believe that there are certain cytokines that generally message to put a brake on things, and the early studies on suppressive mechanisms of T regulatory cells pointed to indeed to production of IL-10 as a means to achieve this the brake signal. But as Faisal commented, more cells can produce IL-10, and
even in the later stage, because you were saying later, so I assume there's more of an adaptive adaptive?
Yeah, but again, late is arbitrary. Yeah? I'm really, to be honest, I'm really looking forward to, let's say, the countries that have very large databases of patients, where they will retrospectively, because I know that a lot of countries are keeping registries where they're collecting the serum samples, sequential serum samples, and then they would be able to retrospectively stratify which patients presented with mild, moderate, severe, critical symptoms, and then associate their cytokine profile, but also their genetic profile with disease outcome.
Which is very important, because, I mean, we talk about we haven't even approached or discussed the HLA gene. And how
exactly, but HLA genes, the HLA polymorphisms, but also the ACE2 expression levels are also greatly dependent on.
Very important. There are a few papers coming out of China that, because we already know of a predisposed genetic mutation in some interferon induced genes.
For example.
Yeah,
but let's say the current literature is highly biased towards the Chinese population.
Exactly.
With their own genetic characteristics. So I'm looking forward to when we have a broader picture of
what's happening in other nations.
Yeah. I know from data from the Netherlands where they're characterizing the the antibody response, and not everything is turning out to be the way, let's say, the textbooks present to us.
Not even all the data is unified. There are lots of debate around the IL-6 involvement and how approaching IL-6 through conventional IL-6 autoimmune drugs like Actimera can possibly help in the pathology. When you see different papers from, like the one you mentioned, Ruan and Zheng et al. And Zhu, each present different readings for IL-6. Of course, as you were saying, the populations are different, the criteria of groups are different. You even look at the papers being published early on in the infection, in the pandemic, like the one I mentioned, Promechera et al. Everyone has a benchmark for IL-6, but they all appreciate that ICU patients all show an increase in IL-6. Is this enough to highlight the importance of IL-6 as a treatment target? And what are the downside effects? Because we do know the involvement of IL-6 in many other functions, especially with the Th17.
Faisal, I think Mushraf makes a habit of posing tricky, challenging questions. So, look, that question I ask myself that basically on a frequent, I struggle with the same question frequently, because again, it comes down to the time point where you're looking at, and also the individual, and also the source of the trigger leading to IL-6. For example, IL-6 can have protective and destructive properties, and these properties are not always I believe, from the pleiotropic nature of IL-6, is that I'm looking for, I thought I put a paper at IL-6 showing both the double-edged property of IL-6. Perhaps I don't have it. It has been shown that in the aggressive aggressive organ dysfunction, for example, kidney. We have a lot of cases with acute kidney injury, and that's also one of the clinical presentations that we use the Soxiris for. The IL-6 can have protective effects for the kidney. They promote the recovery of the.
Are you talking about release of IL-6 in the kidneys. I think that's what you were.
No. I'm saying that the IL-6 can have protective effects.
Yes.
But it can support the general destructive pathology associated with cytokine storm. So, and that is also why the literature is so perhaps contradictory. Is
yes.
Because when you block IL-6, you have a improvement of patient recovery. That is the Chinese. Let me see if I can.
Yes,
yeah, in this
I think Mushrif and only is a combination of IL-6. So it's IL-6 by its own. It's maybe it's not a gold standard, but maybe with supportive therapy.
So far the treatments that are targeting IL-6 alone.
According to the recent publications, IL-6 has been shown is good and effective, especially in the ICU patient and on the ventilator. An interesting paper 2 days ago had provided this evidence using the RNA-seq to characterize the cells and how they behave before and after treatment with the IL-6, anti-IL-6 receptor.
And so, how was the outcome? Was it positive?
Yeah, it showed that the most of the cell, there's a special, not a special, like a monocyte, like infiltrating monocyte in the lung that comes, that play a role.
Yeah, alveolar monocytes.
Yeah.
Yes.
Alveolar monocyte that infiltrated. That it has the special expressions profile. Let me see what is the paper. So they have a high expression of IL-6 and IL-10, TNF. So when they block this IL-6, they show that it's a good impact on the patient.
That's interesting because
I can provide the paper.
The paper that I have on screen at the moment also pointed to that. Personally, I'm very surprised to see these dramatic effects.
Through IL-6 only.
Yeah.
But I think there is many different inflammatory inhibitors, like not only IL-6, but I was wondering about the TNF.
They are. I am sure they're testing.
Mushrif is an expert in TNF. So maybe I don't know if you come across with the.
So what on the heel of what you were saying, Faisal, and on the heel of what Rodney just showed us on the screen, there's Zhu et al., which also discussed the source of IL-6, which is what you elaborated to, the CD14, CD16, CD45 positive monocytes, alveolar monocytes, which have high expression of IL-6 and granular macrophage colony stimulating factors, which are all kind of inducible pro-inflammatory indicators. So at least going back to the first question I addressed wanted to address was the source of these cytokines, which are hopefully Rodney can elaborate on the final point in the cytokine storm. But TNF alpha so far, I haven't seen any papers that have blocked TNF alpha either through infliximab.
In this article that I'm the one is on the screen, the coronavirus puts drug repurposing on the fast track. If I'm not wrong, there was they were referring also to TNF blockade, IL-1 beta blockade, the usual suspects. You know, yes. People are desperate at the moment.
Was it preferential? Did they see good results?
The paper does not go in detail regarding the results. Just the paper was describing actually the current trials or the current research projects looking at potential treatment. And if I recall correctly, TNF blockade was also among these treatment modalities. It's a matter of waiting and see what comes out. I mean.
Well, as you said, there's anti-IL-1 blockade. I have the paper in my hand, actually.
Okay.
So it's anti-IL-1, you were saying, and then you've got the anti-TNF. But no, as you were saying, there are no clear indications, at least in the paper, of what the outcome was. Can you talk to us about the cytokine storm in maybe 3 minutes, and then I want to open the panel for questions. Can you tell us what is the cytokine storm, Rodney?
Yeah, so in a nutshell, the cytokine storm is a state where the cytokine levels observed and the breadth of the cytokines observed surpass the purpose of facilitating the immune destruction of immune-mediated destruction of let's say the invader, and the cytokine storm. This hyper-inflammatory state has adverse effects on the vasculature, on the tissue performance, the cells itself of the organ, and that is the reason why the cytokine storm is such a is a state that you would rather want to prevent, but it's a state also that are sometimes inherently coupled with treatment success. In cancer vaccine world, cancer treatment world, where nowadays they use CAR T cells for treatment of various cancer cells. Actually, these CAR T cells are so efficient, so aggressive, that they also cause cytokine storm while they're identifying and destroying cancer cells. So what is there more to say about cytokine storm? It's a status of deregulated immune activation
or a delayed regulation, I'd say, because what you see sometimes is a delayed increase in TGFs and IL-10, which are, as you were saying to me on the phone the other day, too many too late to control.
Perhaps you could have also, it depends what definition you use, but let's say a very early high level response of anti-inflammatory cytokines would also not be
exactly.
So that's why I like to point to the cytokine storm being a state where the levels of cytokines, the systemic levels of cytokines, do overcome, surpass their original goal to simply control the ongoing immune activities.
Indeed. So we've got a question from one of our colleagues, Dr. Tarfa Turki. If we'll open the panel now for questions, Rodney. I hope you can give us at least 15 minutes, because I know you're in a rush to catch before.
Yeah, sure.
Dr. Tarfa, can you hear me?
Yes.
Yes, what's your question?
Hi. Thanks, Rodney, for an interesting talk. I wanted to highlight the role of my favorite cell, dendritic cell. So you haven't talked much about it today, but just from our talk about IL-6, and we know that IL-6 can recruit a lot of DCs to the lung and let them cause an immunopathology. So from recent papers, actually not recent, but like from our recent SARS-CoV-1 paper, it was suggesting that DCs are being actually as a shuttle to carry the virus to the lymphatic vessel. So it is used by the virus in an immature phenotype with a low expression of MHC1 to carry the virus to the lymphatic, and it's causing either a lymphatic damage. Are we seeing this here? And the other thing, in this form, if it's immature and there's a low expression of MHC1, so we're having a Treg engagement too early and we are not recruiting the right T cell response at the, at the inflammation when it's needed. It is like, it is engaging Treg too soon. So that was a paper like back in 2008, I guess, and it was just looking at upregulation of chemokines by DCs and how the virus is manipulating the immune response through DCs. Can you tell us if you can highlight anything similar in SARS-CoV-2 and what can be the scenario here?
So it's a good question, and I just to point something. I have also it might seem counterintuitive by the presentation, but I have my whole work in the past has been on DC biology. So the reason that I didn't present anything on DC other than the introductory slides is purely because it's at the moment it's a very heterogeneous and what you mentioned about the carrying of viral let's say presenting of viral antigens in the lymph nodes by DC. If I recall correctly, I encountered a paper where they pointed to macrophages having a similar effect, and then I indeed also like you, I wondered whether DCs are also having such a role. I didn't have the opportunity to dig deeper. I would not be surprised at what you're describing for it. If I'm not wrong, you're pointing to a paper describing SARS, the original SARS.
Yeah, SARS-CoV-1.
Yeah. The coronavirus, the SARS coronavirus, they have some intrinsic immune suppressive mechanisms that dampen also the immune activation by antigen presenting cells. So I'm not surprised that that let's say the DCs are not hyperactivated. I believe. Well,
we do see on the heel of what Dr. Tarfa was saying. In terms of chemokines, we do see some DC and macrophage related chemokines like CXCL10 being upregulated. So there must be a role for macrophages and DCs in this pathology.
I think mainly.
No, there's definitely a role for DCs and macrophages, for antigen presenting cells in general.
It's also a source for IL-6 as well. Going back to IL-6. Yeah.
That's the thing. There's other models of not viral infection, but parasitic infection. When we see like toxo, IL-6 does control the recruitment of dendritic cell in acute inflammation. So what I was pointing
as a single cytokine, it controls
rapid recruitment of DCs to the site of infection. So my view was, in SARS-CoV-1, they were highlighting TNF-alpha was the main pro-inflammatory cytokine to cause immunopathology. So I think the scenario here is a bit different. It's IL-6 that's taking the control more than TNF-alpha. So that's why I'm thinking it might be the immune evasion mechanism that we understand from SARS-CoV-1 is that the SARS-CoV-1 is invading macrophages. It might be that it is using DCs as well more to control the acute inflammation and to invade from the immune response. But there is no enough data at the moment. So it's all like suggestions and, from the previous coronavirus.
So to be honest, what I find intriguing of the story is you mentioned low expression of class 1.
Yeah, that was found. Yeah.
Yeah, I find I find it a bit. I would be happy if you could send me this paper, by the way.
Sure. Yeah, I will send it to Mushraf.
But I'm a bit surprised regarding the class 1 expression, because usually class 1 is pretty stable, the expression level. So if I understand correctly, upon infection, the virus creates a state of downregulation of class 1. Is that
so it's not only a mechanism restricted to viruses, but we see it also, if I'm not mistaken, Faisal or Tarfa, even Rodney can correct me, you can see it also with some tumor cells as they expand.
Yeah. So what you see, how to put this?
So the thing that this paper was suggesting that what's happening is that the virus is affecting immature DCs with a low expression of MHC1 and controlling these DCs to carry the virus to the lymphatics.
So it prevents the maturation process of
that's one thing. Yeah.
Thereby leading to diminished expression. So because usually when DCs get infected, they increase the level of expression of the class 1, class 2 molecules.
So this is a good point for explaining why we have a lymphopenia.
Yes.
Lymphopenia.
That was seen in most ICU cases.
Lymphocytopenia, so a drop in T cells.
No, I personally, so I mean, of course there is no black and white. I believe that the lymphopenia is a late outcome. It's not an early outcome. I believe that that's purely speculation, but this is the beauty of the immune system and these open debates. I would argue that the lymphopenia is a consequence of failure of the homeostasis to replenish exhausted T cells. So the viral response is so vigorous that the numbers of T cells peak relatively early without being able to clear the virus, and then the life cycle of the T cell is limited. And when you have this homeostatic regulatory replenishment of the T cells that simply cannot keep up with the viral load, and so the overall picture is that you will have low levels of T cells. That is this paper, and the way I interpret it is that depending on the disease severity, you have the lymphopenia or the exhausted phenotype.
Can I ask a question, and then we have a participation from another colleague of ours, and this is a question for all three, and briefly if we can touch on it before I allow the question for my colleague. As Tarfa mentioned in her question, we do know that in SARS-1 T cells and macrophages are infected. Do we know any of that happening in SARS-2? Because so far.
Yeah. So this paper, this one, it shows that it's a review paper, but they describe the infection of SARS-CoV-2 infection of macrophages.
And do you think that would then have an effect on lymphocytopenia because you have cells?
So to come back to excuse me,
Faisal's comment.
Sorry?
Was it the lymphopenia, Faisal's comment?
Yeah. Your comment that you cannot rule out that this, let's say, the acute immune suppression of antigen-presenting cell cannot be one of the mechanisms leading to the lymphopenia. You know, it's it can be multifactorial.
Factorial, indeed, yeah.
Yeah, but if you would, I speculate that I would be highly surprised if that is the case, because in an acute setting you have such high levels of let's say danger signals being produced that I would argue that those overcome the balance is tipped towards immune activation. At least that's purely my yeah, it's purely speculative. Perhaps in a week or two there will be
more papers, definitely.
Yeah, supporting.
I want to allow one more question from another colleague of ours, and then Faisal, if you can read us some of the questions from the attendees. Ghada, can you hear us? Hello. Ghada.
Assalamu alaikum.
Alaikum assalam. Yes.
Yes, I have. Thank you for great information. My question about if the person infected with the coronavirus, okay, reinfection can be happen or not?
So this thank you very much, Ghada.
Yeah, thank you very much for the question. I think you're also reading the recent literature. It's a very controversial topic, actually. A lot of epidemiologists are hoping that they had it right, but it looks like, or there are data pointing that patients that present mild or no symptoms, they don't produce high enough levels of antibodies, meaning that they can again get reinfected. And that again come back to the original point of the earlier comment, that could indeed point to an acute immune suppressive state, meaning that when the virus infects, the antigen presenting cells are not activated sufficiently to produce the necessary antibody titers that become protective. So to answer your question, they see several patients, especially those that had severe disease that recovered, that they have very high levels, protective levels of or likely protective levels of antibodies. So thereby they are not at risk of reinfection. However, they also see a sub-cohort where they are not sure if these patients would be protected in case of a reinfection. So
interesting.
Yeah,
Rodney, do you have time? I know you're in a rush because there's a lockdown soon.
Yeah, I have a little bit more. Yeah.
Okay, so Faisal, can you read us some of the questions from the attendees? I know you've got a lot of questions in the chat.
The IL-10 treatment.
So who asked the question? Do you have the name? So we can mention names.
Bugami.
Raifal Bugami, okay.
So using the IL-10 as an immunosuppressive treatment.
So yes, immunosuppressive treatments, Rodney. I think we need to touch on that as well, because I know that's also in your line of expertise. From what I've read, immunosuppression, corticosteroids have not shown beneficial effects.
No.
Why and what alternatives are there?
So I don't have a clear answer on the why, because if I understand correctly, it's related to the non-immune mediated adverse effects of corticosteroids, non-corticosteroids on the tissue homeostasis. As a non-clinician, I would I'm not the right person to discuss in more detail what are these adverse effects that limit the efficacy of corticosteroids in COVID-19. So unfortunately, I don't think that I can reliably answer the question why.
What about inflammatory absorption? I know that's where.
Yeah. So what I'm very intrigued by is the either active stimulation of T regulatory cells by, for example, giving targeted IL-2 that, depending how this is administered to the body, can effectively expand T regulatory T cells or of course in vitro cultured T regulatory T cells, so to mimic an adoptive cell T cell transfer approach. But with the adoptive, the in vitro culture, let's say the ex vivo culture, you might be selecting for T regulatory T cells that are not the most efficacious in, let's say, installing immune suppression. I would go with the active approach of stimulating T regulatory T cells, which then by themselves can control aberrant immune activation.
Interesting. Faisal, any more questions?
Is there any genetic predisposition that control the resistance or sensitivity to the coronavirus or not? So in your point of view, this is from Ayat.
Dr. Ayat.
So, thank you for the question. I think also Mushraf touched that topic earlier, that there's definitely going to be a genetic predisposition, especially looking at the HLA molecules. It's just a matter of time before we start seeing which HLA polymorphisms either predispose you to adverse or a protective disease progression. But then that's just one part of the story. You can have also genetic predisposition governing the level of ACE2 expression, and so theoretically, the lower the ACE2 expression, the less virus enters the body, and thus the more likely you are to deal with the relatively low numbers of viral particles. And then not even mention all the polymorphisms associated with different types of systemic immune levels. So I'm looking forward to these publications to get an overall complete overview of what's going on during COVID-19.
Any more else, Faisal?
Maybe this is an understandable question, but I can, in a parallel with the Spanish flu, because the Spanish flu is targeting the young people, and coronavirus targeting in old people. So maybe, I don't know, and they both of them developed a cytokine storm. But can you comment that the difference between them?
First of all, thanks for the question. There are many fundamental differences between the two. The most important one, of course, is that the Spanish flu is caused by the influenza virus, and the COVID by coronavirus. So just based on that fact, they will elicit a different type of immune response. They will also probably have different methods of immune evasion, immune suppression. Also, that is also the entry point of the influenza. I'm not sure. I cannot recall what is the receptor used for the influenza, but the influenza indeed has a general infection pattern that does not distinguish as strongly on age as seen with the coronavirus. The idea that children, I'm a father of a 2.5-year-old myself, so I'm very happy with that. Is the reason, at least one of the hypotheses that people have proposed why children on population basis they do not get as sick is it's been hypothesized that they have lower levels of ACE2 expression, but that is not so strongly proven. But looking at from the immune system is that children, they depending of course of the age, they don't have a fully developed immune system yet that predisposes them to a higher risk for the cytokine storm. And that is one of the theories that I personally feel quite comfortable with, explaining why children are not experiencing the COVID-19 as extreme as adults. So yeah.
Okay.
Just for the matter of the time, Faisal, I'll hate to interrupt, but I know Rodney has there's a curfew that starts at 2:30, I think, Macedonia time.
Yeah.
So we don't want to be locked in at work too much.
Exactly.
From my behalf, Rodney, I want to thank you for the time you gave us. I hope you enjoyed this very fruitful conversation with myself, Faisal, and the rest of the colleagues.
Yeah, very much.
We have a lot of questions that we missed, so I do apologize for the attendees.
Those that want to still pose the question, they can either write me directly by email.
Yes, can you show us your email address, please?
Yeah, sure.
So please,
I cannot guarantee that I will be able to answer everything its value. However, I'm triggered myself very much with this, the discussion and debate. I'm also hoping to receive the paper from the colleague.
It's in the chat from Dr. Tarfa. It's in the chat. She put the paper. So yes, I'll send it to you via email as well.
Okay, thank you very much.
Rodney, at the end of this, I would like to say thank you very much.
Thank you for all the attendees.
Thank you, and hopefully you can attend our future webinars as a guest and attendee this time to see how things are going.
Sure.
Faisal, thank you very much for helping me in this episode.
Thank you very much, and thank Rodney for this nice discussion, and for you, Mushrif, for the inviting me to this webinar.
Anytime, my friend. It's a total pleasure. Thank you all. Thank you, one. I'll see you guys tomorrow. So
yeah,
thank you very much. Take care. Bye-bye, Rodney. Bye, everyone.
Bye.